Hello students, I am Jyotiranjan Das. This is on physics second video on chapter 1 measurement and experimentation. Today we will read about the different type of measurement of physical quantities, how physical quantities are being measured and what are the terms related to this measurement of physical quantities are the today's topic, and this is my second video on chapter 1 9th class physics. Measurement of the physical quantities. Okay, when we say about the different physical quantities, you can see here we are talking about the physical quantities means it is length, mass, time. Okay, these are the different type of other physical quantities we are measuring. To measure the physical quantities, we must use the numerical value of the measure, and that should be multiplied the size of its unit. That means if you want to measure any physical quantities that involve the comparison of the magnitude in size with the standard unit, with a standard unit of the same kind, and that should be multiplied to the same size or size of the units with the numerical value of the measurement. Okay children, you can see here the measurement of the physical quantity involves the comparison of the magnitude of the size with a standard of the same kind. Okay, it can be expressed to any measurement. One should know these following points. Okay, the first point is the unit in which the quantity is measured, means what sort of unit we are using to measure that quantity. The numerical value, second point is the numerical value of the measure, and this numerical value gives the number of times the unit can be obtained, means 5 times, 6 times the numerical value magnitude you must get. Okay, so magnitude of the physical quantity equal to numerical value of the measure into the size of the unit we are talking about. To measure any physical quantity, generally we should use a standard unit. The standard units must have the following characteristics. These characteristics are fixed for a standard unit, for an ideal standard unit. These characteristics are, you can find here, the characteristics of a standard units I have pointed out. It must be convenient in size. Its meaning is any standard unit you are using, that should be convenient in size so that it can be carried from one place to other place very easily, and there should not be any confusion in defining it. Means it should be well defined. The physical quantity must be well defined, and that should not be changed. The physical quantities also should not change with the time, with the place, temperature, pressure. It means change in pressure and change in temperature should not change the physical quantity. With the time and place also it should not be changed. It should be easily reproducible so that it can be convenient to use by everybody. Okay, so these are the basic 4 characteristics of a standard unit of any physical quantity you can find. And 2 kinds of quantities generally we use here. One is called the fundamental units and derived units. Kinds of unit means units can be of 2 kinds we are using here. One is called a fundamental unit and other is called a derived unit. Okay, so fundamental units are generally, they are independent of other. They do not depend on other to derive. They are independent of other unit and they cannot be derived from any other fundamental units. So you can find here the basic example of such fundamental units. You can find there are 7 type of fundamental units are there, and these fundamental units are being listed here. The 7 type of fundamental units you can see: length, mass, time, electric current, temperature, then we can find amount of substance, luminous intensity. These are generally the 7 kind of fundamental units. Length is measured in a meter, and its symbol you can find that small m should be used for it. And mass is measured in kilogram. Okay, and the abbreviation we are using for it or symbol is used kilogram. Time is measured in second. Okay, time should be measured in second. And electric current, this is also a fundamental unit, and it is not depending on any other unit, and it should be measured with the help of ampere. And we are using the unit of symbol is A stands for ampere. It is the name of the scientist, that's why it is a capital letter A is being taken. Temperature is also one of the fundamental unit. Out of 7 fundamental units, this is 5th fundamental unit, and you can find it is measured in Kelvin. Because of the Lord Kelvin, we say Kelvin is again as a name of a scientist, that's why we are using the capital letter K. And substance, amount of substance is generally we measure in mole. So MOL is being used. Amount of substance means how much amount of substance, whether it is 10, 5, 15, 20, okay, fixed number of quantity. As we said, dozen means or 12, course means 20, like that. Mole means generally is measured for amount of substance. The mole has got a fixed value also. So you can find the luminous intensity. This is actually used for the light intensity. That means if a bulb is being lit up, how much will be its capacity of lightning in area, intensity of light. That's called luminous intensity, and is measured in candela. Candela's abbreviation or symbol is stands for CD. Candela stands for CD stands for candela. Candela is actually, suppose I will say this bulb is of 100 CD, means its meaning is 100 candles. If you lit up, how much electricity, I mean lighting is being provided, that is the capacity of that bulb we will talk about. So these 7 fundamentals what I listed here, the length, mass, time, current, electric current, temperature, then the amount of substance, luminous intensity, these all are the basic fundamental units. To derive, we never derive these all. They are fundamental units and they are independent of any other unit. Okay, so you can find some of the fundamental units definition is being given. They are independent and they cannot be derived from any other physical quantity. But as the name indicates, that second one is called derived. Derived unit, they are generally expressing by using the fundamental units. We are using the fundamental unit to explain this derived units. So derived units are generally derived from the fundamental units. So some of the derived units you can see like density. Density is a derived unit, and you can see so many area of derived units are there. So many. This table you can find area is a derived unit. Volume, density. Density can be derived by mass by volume. Mass is a fundamental unit, is measured in kilogram. Mass is measured by using the fundamental unit kilogram mass, and volume is measured in length. Okay, volume equal to length into breadth into height, length into length, I mean the meter into meter into meter. This gives you mass by length. You can see here length q, that is a kilogram divided by LQ or kg meter to the power 3, because we can find minus 3 here. Mass by volume, density is formula is mass by volume. Mass is measured in kilogram and volume is measured in meter cube. So if you explain this one, kg meter to the power minus 3 is come. Similarly, you can go for the other type of force. Force is also mass into acceleration. Force can be derived by using the fundamental units. Pressure, force by area. So you can see here these all are the derived units. Volume is some example of the derived units. You can see volume, density, speed and velocity, force, pressure, energy, acceleration, frequency. These all are derived units. So in today's video we found here what are the measurements of the physical quantity and how can we measure. Characteristics of the standard units. What should be the standard units character, means everything cannot be taken as a standard unit. There should be a fixed character, and this is a 4 character. At least it should satisfies to become a standard unit. And using the fundamental units are the also called base units. They are of 2 kinds. Units can be of 2 kinds: fundamental unit and derived units. So fundamental units are 7 type. I already said and show the table. And derived units are generally we are using the using the fundamental units to derive them. So in today's video we come across of these fundamental units and their measurements. So basically here you must learn what is the fundamental units and what is its definition. It should be independent of other units and it should not be derived from the other unit. But derived units are generally depend on fundamental unit and we are deriving them by using the fundamental units only. So thank you. In this video we are learning this about the fundamental units and the derived units. Thank you.